Good morning. So we are talking about, everybody say good morning. My class is so excited that we're recording again. We are going to talk about polynomial operations today. What happens when we want to add, subtract, multiply, and divide polynomials. And so we're going to start by doing one of each of our problems, and then we will maybe add to it after we finish that. So let's talk about what happens if we want to add polynomial functions. So the first thing that we're going to do is just add. An example of adding polynomial functions would be f of x plus n of x. And so we're going to take our function f of x, and we are actually going to plug it in. We'll use red to plug in f of x as x minus 3. And just because I'm trying to save us for heartache later, we are going to use parentheses when we plug into this equation. So we're going to plug in f of x as x minus 3. And we are still adding, and we are going to find n of x, and we are actually going to use parentheses to plug it in as well. 2x to the third minus x squared plus 2x plus 1. And when we add these two functions, we have to decide, because we're adding, we're only combining like terms. If you want to go in this order, you can say, do I have any other x's? And if I'm looking, I do have other x's. I have a 2x. I can't add an x to an x to the third, because this is like saying I have one apple. X to the third is not another apple. I can only add it to something that looks the same. So 1 apple plus 2 apples is 3 apples. It's 3x. So now I've used both of those. If I try to combine my minus 3 and plus 1, then that is going to give me, well, it's a negative 3, so it's got to be negative 2. And then I really don't have anything to combine this 2x to the third. It's a plus, so it's a 2x to the third, but I don't have anything to combine with it. I cannot combine my x to the third with the x squared or anything else. So I just those aren't going to change. And then there are plenty of us who are OCD who this is driving them crazy. If I look out, I know there's someone in my class who can't stand this because these are not in order. So remember a long time ago, probably back in Math 1, we talked about ascending order and descending order. We typically write polynomials in descending order, which means the degree or the number of variables that we have goes down. So here we have 3 x's, 2 x's, 1 x, and no x. Mr. King, you okay over there? Oh. Anybody have a question for me? Anybody need more time? Great. So now if we try subtraction of polynomials, when we want to subtract polynomials, and we can do something like n of x minus m of x. I'm going to go up here and get my n of x, and I'm actually going to write it in parentheses again, 2x to the third minus x squared plus 2x plus 1. And then I'm going to subtract my m of x, which is x squared plus 3x plus 2. Sorry for the interruption. Okay, so if we're subtracting, what we have to remember about subtracting is that we're not just subtracting the x squared. We're subtracting everything in this entire function. So my suggestion to everyone is that we change this minus to a plus, and then we distribute that negative to everything after it. So if these are all positive, then they all turn negative. If one of these was negative, then it would turn positive. So we're going to distribute that negative, and now we need to combine like terms. I have a 2x to the third. Do I see any other x to the thirds? No. So we just keep that 2x to the third. Then my next term is negative x squared. Do we see any other x squareds?
Yes.
Yes, we have another negative x squared. So a negative 1x squared and a negative 1x squared give me a negative 2x squared. Not combine the exponents. If I have 2x, I can combine that with my negative 3x, which gives me negative x. And then I have 1 and negative 2, which combined give me negative 1. So with subtracting, the number one mistake that I see is we tend to subtract the first term, but then we don't just subtract the other two.
You do that every time, like change to an addition and then.
I do. When I do, because I'm sloppy, like I know that about myself. Look at my desk. I'm a mess. So to keep myself from making a mistake, I don't try to remember that I'm subtracting. I actually write plus, minus, 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 and I change the sign. All right, multiplication of polynomials. I told you guys to, bless you, I told you guys to write down these first three, but I'm going to cheat, and I'm going to use g of x as well real fast. The reason why I want to show multiplying, when we multiply polynomials, if we have f of x times g of x, I really want to talk about how we can use what? Someone had already said it earlier today. I think it was you, Paul. When you have a binomial times a binomial, that's when you can use FOIL. We have typically always said that a binomial times a binomial, we are going to multiply the first, the outer, the inner, and the last. So that's where FOIL comes from. F-O-I-L. First, outer, I only need one T. Inner, and last. So my first two terms are going to be x times x, which gives me, now we're changing last names, right? Now we're multiplying. X times x is x squared. My outer are going to be my x times positive 2. So plus 2x. My inner are going to be the negative 3 times x. So that's negative 3x. And my last are going to be negative 3 to 2. Negative 3 times 2 is negative 6. And at this point, after we use FOIL, we still have to clean this up. What's my issue? We've got a 2x and a negative 3x, right? And so that's going to leave us with a final answer of x squared minus x minus 6. I'm going to hope that I didn't hear what I think you just said. All right, need more time or are we okay? We good? So far? All right, so let's multiply one that's a little more, just a little more. We don't want to call it difficult. What could we call it? Hard. We did, for our jump start, we've already multiplied f of x times m of x, right? I think those were the two, or g of x times m of x. Let's look at what happens if we want to multiply f of x times n of x. Now, I had someone say, Miss Troxler, we talked about how we are going to just distribute, and she called it what? The claw?
Yes.
She called it the claw. Anybody else have Miss Troxler and she called it that? Okay. Like you're going to have to distribute this x to this one, and this one, and this one. And then we also have to distribute here, 2, 3, and 4. But I'm going to do it a little different. This is perfectly fine. If you like that, I'm all for it, as long as you get 8 terms and you add them together. But like I just admitted about the subtraction, I'm a mess. I know this about myself. So what I'm going to do is create a box. I have 2 terms in my first polynomial. I have an x and a minus 3. And I have 4 terms in my second polynomial. I have a 2x to the third minus x squared plus 2x plus 1. And that is going, when I multiply, I get 2x to the fourth minus x to the third plus 2x squared plus x, and then I multiply everything by negative 3, so negative 6x to the third plus 3x squared minus 6x minus 3. And the reason I like my box is because what do you notice about the diagonals? I have a 2x to the fourth, but look here. Both of those are my x to the third. So when I combine them, I get what? I heard it, negative 7x to the third. I combine these and I get 5x squared. I combine, let me get it purple. This gives me minus 5x and then my minus 3. You are welcome to just multiply and write them all out like you did. That's fine. I could care less. I don't care how you do it. This is for me. For me, I have to keep myself organized, or it helps me keep myself organized. Now, so far in life, we have only divided by, like, we've taken a polynomial. These actually won't work for the type of division that we have done. So far, we've only done something like 4x to the third minus 2x squared divided by 2x. And that's when you just divide each term by 2x. And you get something like 4x squared minus x. Because the 2's do what?